Greetings students. Today one question was asked very often during my office hours, and I'd like to consider this problem together with all of you, and just in case you have a similar question, I'll provide an answer for you. The question was concerning problem 1 and 2 when you have to do complicated partial fraction decompositions. So the question is, how would you do it? How would you do it to avoid painful solving of 4x4 system of equations? What I want to demonstrate today is how we can do things with Mathematica just to simplify the algebra. Of course you can use the part command just to give you the partial fraction decomposition. But that would not tell me how you understand the problem. And I want you to explain to me that you do understand the problem when you're doing your homework. So when you're doing partial fraction decomposition, you end up with a system of equations for your coefficients a, b, c, and d, etc. And obtaining these coefficients is the important part. You can use Mathematica to solve the systems of equations, but I need you to show me how you got to those systems of equations. And here's how I can do it with Mathematica. So after a little bit of algebra, you should get this kind of equation. You've got the term ab, you've got the term as plus b for one of the fractions, and that needs to be multiplied by s minus 3 squared. You also have a term with c, and I'm using double c just because single c is taken in Mathematica. It's a built-in symbol, and that needs to be multiplied by s minus 3 and s squared plus 4. We also need to have a term with d coefficient, and again the symbol d is taken, so I'm just going to use double d. That's multiplied by s squared plus 4, and that should be equal to s cubed minus 6s squared plus 16s minus 34. If you got to this part, you're doing things correctly. Alright, what can we do? We can start plugging in numbers, and Mathematica can plug in numbers for you. For example, if we plug in s equals 3, this equation simplifies into equation for d only. Mathematica has a replace all command that does the replacement or plugging in for you. It needs to provide an expression and a rule of what replace with what. So the rule that I'm going to use here is s, and I'm typing in minus greater and press 3. So the rule is all instances of s have to be replaced with 3. If I evaluate, I get that d has to be -1. Unfortunately, there is no other value of s you can plug in to get such easy equations. So what else can we do? I can use the collect command to collect all powers of s. And its syntax is very simple. You give it the expression and you give it which terms to collect. What it has done is joined together all the things that have s cubed as a multiple. It also has all the things that are multiplied by s squared together and all the things that are multiplied by s. You can easily see that you can make up 3 equations for a, b, and c using this decomposition. You can definitely see that a plus c has to be 1, and this expression has to evaluate to positive 16. So this will give you a system of 3 equations. And 3x3 systems of equations are quite easy to solve. You can use the solve command to make it solve for your equations. So for example, what if I need to solve the equations a plus b equals 2, and I have to use double equal sign, and a minus b equals -7, again double equal sign, and I need to solve for a and b. Solve can solve systems of linear equations. And this is what you can do for your homework. You will write the systems of equations on your piece of paper or whatever you use to submit the homework. And you say that these are the equations that you have, and these are the equations that the coefficients a, b, c, and d have to satisfy. And then you use Mathematica to solve these equations, and you provide me with the solution. And again, let me repeat, you only need to do this for the problem 1 and 2. For problem 3, it's okay to stop when y of s has a complicated form, like for example this fraction right here. So once you obtain an expression like this, you're pretty much done with the homework, or with the problem 3 in the homework. You will need to compute the inverse Laplace transform in part 4, in the third part of this problem. I also want to say a few things about how you can verify that something is indeed a solution. I did it in the lectures, but let me just do it here again. So for example, suppose you got an inverse Laplace transform of some expression. Let's just go with something easy. That's the expression you have. And you want to see if this satisfies the differential equation. So we're going to introduce a new function that has t as a parameter, and we use underscore. And that's just a format that Mathematica requires you to specify new functions. If you evaluate, I've defined a new function. And I want to see if this expression satisfies the differential equation y double prime of t minus, I don't know, I'm just going to make something up, 2yt equals x of minus 3t. Just want to see if that's true. And what we get is the right hand side evaluates to x of minus 3t, and the left hand side evaluates to 7e to the minus 3t, so the equation is not satisfied. You can use similar technique to check if the solution you generated with the inverse Laplace transform satisfies the differential equation given to you in the problem 3. So that's pretty much all the comments I have about this homework. Hope this helps you with your homework.